Hey, guess what? I've been diving deep into the world of Python programming, particularly focusing on the concept of the return keyword. It's fascinating stuff, really. Python functions are so versatile, and the return keyword is at the heart of it, allowing functions to produce results that can be leveraged elsewhere in your code. It's a game changer for writing efficient, reusable code. In Python, when you define a function, it's not just about encapsulating a block of code. It's also about controlling the data flow within your program. Enter the return keyword. It sends the result of the function back to the place in your code where the function was called. Think of it as a friendly handshake between different parts of your code, ensuring that data gets where it needs to go. Let's start with the basics. A function that has a return statement will terminate execution and return the specified value. Without a return statement, the function simply completes its execution and exits, but Python automatically returns none to indicate the absence of a meaningful result. Remember, it's good programming practice to think about what your function is supposed to return and only use return keywords when you need to send back a meaningful value. Consider this simple example: Python definite square, return number 2 if x%2 is equal to 0 else x. As I said, nested functions and closures are a no-go here in Python, but we can still return in lambda functions to apply transformations or to apply a function on elements of a sequence. Now, async functions and coroutines are a different breed of beast. These functions, designed to work with asyncio, allow a function to yield control back but not for the return of data. The await keyword is used instead to pause the function until an awaited coroutine finishes. Python async definite fetch underscore data. Imagine something here that takes time: await time underscore consuming underscore operation return processed underscore data. In this context, a return doesn't pause the execution. Instead, it's the yield that manages the asynchronous operation, allowing other tasks to run during this blocking operation and providing a responsive experience. Now here's a fun fact. The Python documentation provides a simple way to use a return statement without even writing any function calls. Just return the expression directly. Python definite example, return 42. It's always good to read the documentation to make sure you are using the language to its full potential. It's also common to use return in handling exceptions too. Here's an example where we raise an exception inside the function and handle it using a return statement to gracefully exit under an error case. Python definite divide, if b is equal to 0, return error return ab. One final word on best practices with return: always return consistent data types, which helps maintain code reliability and ease of debugging. I hope this discussion gave you a good perspective on just how useful and how vital the return keyword is in your Python toolbox. Remember, coding and returning results in Python can lead to a smooth and efficient execution of your projects. So, now you understand the power of the return keyword and how this simple statement controls the flow of data in your code. If it's been a great journey discussing the return keyword and its use cases, subscribe to follow more such Python insights. You can find me at neeraj.qzz.io for more. Until next time, happy coding.